want to look at saturated vapor pressure calculation. Now, um, it's very important to know the saturated vapor pressure and the actual vapor pressure, the relative humidity, and the air density. They are very important parameters to determine the the amount of water that has been stored in the atmosphere. And that is what will yield into the formation of precipitate or clouds that would eventually what precipitate. So it's very important. Now we need to know, if you look at the saturated vapor pressure curve, you realize that if I have an actual vapor pressure, its corresponding time is the due temperature, right? The dew point temperature or the dew point. Then if I have the saturated vapor pressure, its corresponding time is the temperature of the actual air. Do you get it? Or just the normal temperature or the air temperature. So if we are using the curve, if we look for the actual vapor pressure or the unsaturated vapor pressure, it will give us corresponding dew point temperature. If we use the saturated vapor pressure, it will give us the air temperature or the temperature for the unsaturated air. Do you get it? So you need to know. So in this case, we are not going to use the curve, we are going to use the relation. So the relation that we are going to use is E is equal to 6.11. Let me make it EN. Is equal to 6.11 times E exponent, open bracket, 17.27 T, let's say N, over 237.3 plus what? Tn. Now, if I use ES, then the T that would be what? Normal T. But if I use E, then the T will be what? TB. Do you get it? So if I put E here, then it means that the T that I'll put here is this. So this ES is saturated vapor pressure. Let's take note. Saturated vapor pressure. This T is what? Air temperature. Right? Then E is what? The actual vapor pressure. Actual vapor pressure. Or you can see the unsaturated vapor pressure. Then TD is what? Dew point temperature. Dew point temperature. Now, this what happens when the temperature is in dew point, we get saturated vapor pressure. We get it. Now, when the temperature is at air temperature, we get actual vapor pressure. But the relation doesn't relate them. The relation that we use to find these parameters, it relates the saturated to the normal air temperature, and it relates the unsaturated to the dew point or temperature. Although the dew point temperature will give us the saturated. So you need to know the difference. Do you get it? In real life, the dew point, when the temperature cools to dew point, then we are going to have a saturated air. Do you get it? But in terms of mathematical expression, the mathematical expression or the graphical relation, if when we look at the graphical relation, you see the mathematical expression relates the saturated and the air temperature, and it relates the actual or the unsaturated to the dew point. So we need to take note. So let's see this question that was given to us. Let's see how we go about it. So the question said that at a weather station, the air pressure is 101.1 kilopascal. The air temperature is, so that is the normal T. So let's write our parameters. So the pressure is what? 101.1 kilopascal. Then the air temperature, that's normal T, is 22 degrees Celsius. And the dew point temperature, TD, is what? 18 degrees Celsius. So they say we should calculate, the first one is to calculate what? The saturated vapor pressure, ES. So in that case, we used our equation. So it means that ES equals to 6.11 times E exponent what? 17.27 T over 237 point what? 3 plus T. So because we are looking for ES, the T that we put in is this T. Are you okay? So now let's find it. So it means that ES will be equal to 6.11 times E exponent. Let me use this to show the exponent. E exponent 17.27 times 22 all over all over 237.3 plus 22, right? And this will give us what? If you use your calculator, you're going to get the saturated vapor pressure to be what? 26.447 millibar. The answers are here, yeah, but these are approximated answers, right? So yeah, these are approximated answers. But if you use your calculator, you see that you are going to get this. Are you okay? Right. Then we go for the B. The B is asking us to find the actual vapor pressure, so our E. And so in this case, our E will equal to 6.11 times E, you get it, exponent. Now this E is different from this E. This E is actual vapor pressure. This E is the constant, the opposite of length. You get it? The opposite of lateral logarithm. You get it? So this E is the actual vapor pressure. So let me change the color so that to differentiate them, that they are not the same E. So this E is equal to them. So we are going to get 17.27 TB. You get it? Over 237.3 plus what? T what? B. Are you okay? So we are going to get E to be equal to 6.11 by E exponent 17.27 plus what? Sorry, times 18 times what? 18 all over 237.3 plus what? 18. And so E will be equal to what? 20.647 millibar. Have you seen that? So this is going to be our answer for that. Now let's look at the questions, the C. Now the C is asking us to find, so let me put the C here. It's asking us to find the relative humidity. Now the relative humidity is equal to actual vapor pressure over the saturated vapor pressure times what? 100%, right? So the relative humidity, the actual vapor pressure was 20.647 over the saturated vapor pressure, which was 26.447 times 100%. Now here the units are in millibars, so the MB is with millibars. Are you okay? Yeah. Right. So let's take it. The units are in millibars because the equation gives us the answer in what? In millibar. Right? The equation gives us the answer in millibar. So let's take note of it. So the relative humidity, after doing this, finding this expression, we are going to get what? 78.069 what percent, and that's the relative humidity. Now the next question is for us to find the air density. The air density. So we do it here. So the air density, that is, so that will be my D, air density, and it's given by, so there are several relations that we can use to find the air density. So the first is relation that we can use is how do you call it? The pressure over the gas constant times the temperature. We can also use this equation, that is the density. I mean, we can also use the equation. The density is equal to the pressure minus 0.378 multiplying the actual vapor pressure over the gas constant times what? Temperature. Alright, so in these two scenarios, we are going to take this one, then we are going to take this one, then we take this one. So taking the first equation, we can see that the density of the air is equal to, in the question they give us what? The air pressure, right? That is V. So the air pressure over the ideal gas constant times temperature of the air in Kelvin. So in this case, the, how do you call it? The air pressure, which is 101.1 kilopascal, so 10 to the power 3 over R. R is equal to 287.05. That is the ideal gas constant, 0.05. Let me write it again. So that constant is 287.05 joule per kilogram Kelvin. Right, so I just write it here. That is 287.05 times the temperature. Now the temperature was 22 degrees. The air temperature was 22 degrees. So we have to find it in Kelvin. So plus 273. And that is what? 295. So times what? 295. And that will give us what? 1.193 kilogram. So approximately it's 1.2 kilogram. Have you seen that? So yes. So we can use that style and we can, so basically what we are finding is, let me pan down. So basically what we are finding is the air density, right? And this is the relation for finding the air density. The air density is equal to the air pressure over the real ideal gas constant times the temperature of the air pressure. So in the question, they say that the air pressure was this 101.1 kilopascal and the air pressure was 22. So here you use the parameters for the unsaturated air. Do you get it? Unsaturated air. That's what we use. So we are done with the first part. Now, what if you are using this equation? You are using the second equation. Now, the second equation, which is the, so with the second equation, we need the pressure in millibar, right? So the pressure, which was the air pressure, which is 101.1 kilopascal, we need it in what? In millibar, and that is So how do I put this? Milli is to the power. So if I want to change this to millibar, it means it's 101.1 times 10, right? It's going to give me what? 101 millibar. So you just, if I want to convert pressure to millibar, I just multiply it by what? By 10. That is changing the unit from kilopascal to what? Millibar, right? Now, if I change it to millibar, then I can use this equation. Now, for this one, because we are working in millibar, the ideal gas constant is what? Is 2.87 by 10 to the power 3 millibar centimeter cube per gram Kelvin, right? And our temperature will still be in Kelvin, so 22 plus 273, that is what 298 what Kelvin. So let's put everything inside. So we are going to get the density of the air to be what 101 minus 0.378. Now the E there is the actual vapor pressure, which is what 20.847 all over 2.87 by 10 to the power 3 millibar. Now we have to change this centimeter cube. Yes, we are supposed to change it centimeter cube to meter cube, right? So that will be times 10 to the power negative 6 meter cube, right? Over gram Kelvin. So our density we are going to get, let's find out. So I forgot to add times the temperature. So times the temperature, which is what 294.5. So we are going to get 1184.89 grams. So if I want to change it to kilogram, 123. And so the density will be 1.4184 kilogram, which is approximately 1.2 what kilogram. And that'll be it for this question. See you in the next video. Bye.